Next up. Okay, so question number 4. Find the value of the discriminant and determine the nature of the roots of the quadratic equation. So we're given a quadratic equation, negative 4r squared minus 4r is equals to 6. So first of all, don't get confused that why is it not in terms of x. The quadratic equation can be in any term, meaning the variable can be x, y, z, whatever. In this case, the variable is r. To make it look more like a quadratic equation, what we will do is we will take the 6 to the other side, or you can say we would subtract 6 from both sides, and we would get negative 4r squared minus 4r minus 6 is equals to 0. And then we would multiply the entire equation by negative 1, which would give us 4r squared plus 4r plus 6 is equals to 0. So this is the quadratic equation in hand, and what we have to do is we have to calculate the determinant of this. The good thing about the determinant is right off the bat, if we calculate it, we will be able to estimate what the roots or the nature of the roots. So when I say the nature, I mean to say if the roots would be real or not, and how many roots would I have, if I would have one root, or if I would have two real roots, or if I have no real roots. So the determinant is represented by capital D, and it's equal to b squared minus 4ac. So now what is b squared, you'll be asking. So the generic quadratic equation is represented as a is equals to a, or y is equals to ax squared plus bx plus c. So in this case, we're given a to be 4, b to be 4, and c to be 6. So if I were to plug all of them in, for the determinant value, I would get 4 squared minus 4 times 4 times 6 is equals to 16 minus 16 times 6, which is 96. So the final value would be negative 80. So a determinant is actually negative. So now, in order to be able to identify what would be the nature of the roots, we need to know 3 properties of the determinants. So the 3 properties of the determinants are, first, if determinant is greater than 0, we can say that the quadratic equation has 2 distinct real roots. Second, if d is equal to 0, we can say that the quadratic equation has just 1 distinct real root. And lastly, if the determinant is less than 0, we will have to say that there are no real roots. In our case, since d is equal to negative 80, we would come to the conclusion that for the equation let's see, what was the equation again? Yeah. So for the equation minus 4r squared plus 4r plus 6 equal to 0, we can say that there are no real roots. Okay. So the key takeaway from this question is we need to know the 3 properties of the determinants. We need to be able to solve for a, b, and c in the standard quadratic equation form. Using that, we need to be able to calculate the value of the determinant, and then from the value and the properties we would know the nature of the roots. or the solutions for the quadratic equation. Okay, so let's verify as well. So these are the three cases that has been presented. The equation A equal to 4, B equal to 4, and C equal to 6. And we get negative 80, and which is less than or equal to 0. Therefore, it has no real roots or solution. So the answer in this case is correct.